Let's look at some applications involving quadratic equations. Here's one that should look familiar. I've mentioned it a couple of times before. Let's say a compass is accidentally thrown upward and out of a hot air balloon at a height of 300 feet. The height h of the compass above ground x seconds after it was thrown is given by the equation h equals negative 16x squared plus 20x plus 300. The question is, how long will it take for the compass to fall and hit the ground? Well, remember, the ground, by definition, is at a height of 0. So the height, or h, equals 0 on the ground. So to solve this, I would want to set h equal to 0 as a first step. And then I need to find x because I'm trying to figure out how long, and remember x is the time. So when you look at this, this is a quadratic equation because the x squared. I have 0 on one side. If I can factor the other one, I can use the other side. I can use the zero product principle to solve the equation. Now, this side is written in descending order, but I have a negative out front. Remember, I've mentioned that if you have a negative in the beginning of something that you want to factor, you should factor it out. And the other thing we should always factor out is something common. When we look at 16, 20, and 300. They all are even, so they at least have a 2 in common. You should also check to see if they have a 4 or an 8 in common. I think they have a 4. Let's try it out. Instead of just taking a 4, I'm going to take a negative 4 out of all 3 terms. So negative 4 removed from negative 16x squared is going to give me 4x squared. 20x divided by negative 4. Remember, I'm taking a positive divided by a negative, so I'm going to get negative 5x, and then 300 divided by negative 4 would be negative 75. Now, one thing you'll notice, and you may not have been able to do the 75 in your head, is that in word problems, you have much more interesting, or you might say tricky, numbers that you're going to be working with. They won't be book numbers. They're going to be numbers that kind of represent more complications that the real world has. So feel free to use a calculator on the word problems. On testing situations, I will always allow a calculator related to word problem situations. All right, so it looked like 4 went into everything very nicely. We couldn't have taken an 8 in because notice the 5 and the 75 are odd, so that's as far as we could go. We should keep factoring though because we have an x squared, so keep going. The negative 4 just stays out there. What we want to do is factor this 4x squared minus 5x minus 75 into binomials. Now I can use that 4x squared and the 75 to factor into the first and the last positions, and I need a negative 5 to come up. We can go ahead and use trial and error, or we can use an AC method. If you use an AC method, you're going to get 4 times 75, which is 300, specifically a negative because of the negative 75. And you can go ahead and look for factors that add up to 5. Now, if I start at negative 1 and 300, that's going to take me a while. Those are quite a ways apart if I add them together. So you might want to think about jumping and going negative 10 times 30, say. Those are 20 apart. That's in the right direction. Or maybe say 15 and 20. That's close. 15 times 20 is negative 300. If I wanted to have a negative 5, though, I should have a positive 15 and a negative 20. Now, I'm using the AC method, so before I put those numbers back in, I have to adjust by taking out the 4. So I'm going to use the shortcut method where I divide these numbers by 4. I wasn't using those, so I'll cross them out. And I'm going to simplify. So 15 over 4 actually doesn't simplify, so I can write that into my first factorization as 4x plus 15. And the second one does simplify, and it simplifies to negative 5 over 1. So now I'm going to use x minus 5. Take a moment to double check that calculation that you factored that correctly. So I'm going to do a little check over on the side. 4x times x is 4x squared. Outside terms, negative 20x. Inside terms, positive 15x. And lastly, I have 15 times negative 5, which is negative 75. There's my first term that I wanted, 4x squared. My last term is negative 75. When I add up the 2 in the middle, I do get the negative 5x. So that's good. A lot of this work on the side here that I've shown, I might do on a piece of scratch paper that I just have around. we now have a factorization equal to 0. So I have -4 times parentheses, stuff in the parentheses of 4x plus 15, and this other parentheses of x minus 5. So I can set each of these factors equal to 0. Now, -4 can't be 0, so usually we just ignore that one. Okay, remember the zero-part principle says at least one of them has to be 0. If we set 4x plus 15 equal to 0, we can subtract the 15 from both sides and then divide out the 4. With x minus 5 equal to 0, it's actually even easier. Just add 5 to both sides. We get two solutions. We get x equals -15/4 and x equals 5. Now, what was x in this problem? A little reminder, x was the seconds since the compass has been thrown out of the hot air balloon. When we talk about time, it doesn't make sense to have a negative. So this becomes what's called an extraneous solution. It actually works algebraically, but it doesn't work in the context of the problem. 5, though, is a positive 5. It makes a lot more sense. 5 seconds later, the compass has hit the ground. We could check that real quick to make sure it is correct. I'll come over to the side here. I could put the 5 in, -16 times 5 squared plus 20 times 5 plus 300. And I could calculate this out. And since I mentioned you can use your calculator, I would just throw that all into a calculator, -16 times 5 squared plus 20 times 5 plus 300. And when you say equals and your calculator throws that together, you will get that 0. So that confirms your answer. So to answer a word problem, we'd always want to state our answer in a sentence that refers back to the situation. We were asking ourselves, how long would it take the compass to fall and hit the ground? It's going to take 5 seconds. So we'll say it takes 5 seconds for the compass to hit the ground. So there's our first example involving quadratic equations, and this example that's been coming back repeatedly, all solved.